All right, so number 20 was the first one you had a question on. I'm going to be up front for your time and just for, benefit versus time. I think we're going to skip this one. It's something that would not be on the AP exam this year. The radius of convergence, interval of convergence, neither are included on this year's exam. So we're going to go ahead and bypass this one. The next one that you had a question on was number 23. 23 is going to be an integral with u substitution. So I'm going to let u equal e to the x minus 1. Then my du is going to equal e to the x dx. All right, I'm going to find my new bounds right now as well. So the old upper bound was ln of 2, so e to the ln of 2 minus 1, that equals 1. The old lower bound was 0, so e to the 0 minus 1. All right, e to the 0 is 1, 1 minus 1 is 0. So now I've got an integral from 0 to 1 of 1 over 1 plus u squared du. All right, we should recognize that structure as being arctan. So I have arctan of u evaluated from 0 to 1. So I have arctan of 1 minus arctan of 0. That's a pi over 4 minus a 0, which is pi over 4. So our correct answer would be C for number 23. And again, the big topic is integration with u substitution. Now, if I keep moving forward, your next question was number 25. All right, number 25 is a related rates problem. So they tell us that the volume of a sphere is increasing at 6 pi cubic centimeters per hour. And it asks us at what rate in centimeters per hour is the diameter increasing with respect to time at the instant the radius is 3 centimeters. So when radius is 3, we know that diameter is going to be 6. All right, so that might come in handy in this problem. We also know that the radius equals the diameter over 2. All right, which is another thing that might come in handy in this problem. So they want us to relate the change in volume, which they gave us, and find the rate of change of diameter, right? Because it asks, is its diameter increasing with respect to time? All right, so they want to know what rate. So I'm going to take this volume formula they gave us, and I'm going to rewrite that so that it's in terms of d instead of r. So I have 4/3 pi, and then in here I'm going to have d over 2 cubed. All right, so that's volume equals 4/24, because 2 cubed is 8. 8 times 3 is 24. 4 over 24 is 1/6. So I have 1/6 pi d cubed. All right, now I'm going to take the derivative of this with respect to time. So I have dv dt equals, I'm going to bring the 3 out front. 3 over 6 is 1/2 pi d squared. All right, and then I'm going to have to multiply by dt because we're taking the derivative implicitly. All right, now at this point it's really up to you. I prefer to just go ahead and plug values in right now. So I know dv dt is going to be 6 pi because I was told that in the problem, and it is increasing, so that's positive. All right, then I've got 1/2 pi. We're curious about the moment when the diameter is 6, so I'm going to toss a 6 in there, squared, dt. All right, so if I take that over, and we'll just come over here to the side, I've got 6 pi equals 36 times 1/2 is 18, so I have 18 pi dt. If I divide both sides by 18 pi, the pi's are going to cancel. 6 goes into 18 3 times, so I have 1/3 equals dt specifically when r equals 3. So I go to my answer choices. That is choice A. So I'm going to go ahead and choose A on that one. All right, now we jump to 26. 26, it says the function f of theta, all right, is this function that's given, satisfies f of theta is greater than or equal to 0 for theta greater than or equal to 0. During the time interval from 0 to 2 pi seconds, all right, a particle moves along the polar curve r equals f theta so that at time t seconds, theta equals t. All right, on what interval of time is the distance between the particles the particle in the origin increasing. All right, so this one, in all technicality, shouldn't be on this year's AP exam because they've kind of said we're not going to deal with the polar and the parametrics. I would argue that the way this is written, we know that the function f of theta gives you the radius. So the radius equals f of theta. But we know during the interval that we're concerned about, theta is equivalent to t. All right, so that really equals f of t, which equals t cubed minus 6t squared plus 9t, as long as 0 is between, or as long as t is between 0 and 2 pi. So now from here, it wants to know when it is increasing, so I'm going to take the derivative. F prime of t equals 3t squared minus 12t plus 9. And I'm going to factor a 3 out to make it easier to factor. All right, and I'm going to get a t minus 3 and a t minus 1. All right, as my two factors. And those are the factors of f prime of t. All right, it wants to know when the particle is increasing. So I'm going to get a number line here. And we're from 0 to 2 pi. All right, we have a 1. And we have a 3. All right, so we're going 0, 1, 3, and 2 pi are the numbers. And what we need to do is we need a sign test in here. So I'm going to plug in a half. On a half, I've got negative, negative, which is a positive. So this is a positive derivative over that interval. From 1 to 3, I'll pick a number 2. 2, I'm going to have negative for the first factor, positive for the second factor. That's negative. Then I'm going to go to the third and final section, and I'm just going to pick 4. All right, 4 is positive, positive, so that's positive. This asks me when it is increasing, all right, when the radius, the distance between the particle and the origin, is increasing. So that's going to be from 0 to 1, and then from 3 to 2 pi, all right, which ends up being our choice D. So again, I really like the optimization, or sorry, the determining whether it's increasing or decreasing, but the contextual layer of the polar, I think, puts it outside of the range of how they'd ask a question. But if they framed it without saying it was polar and just saying the radius was given by that function, I think you could still answer it. All right, so there's 26. And then let me see which other ones, if any, you had. All right, I think that might have been it. So those were all the ones that you had a question on, with the exception of that very first one, 20. It would really be an extension for me to run through it right now. Happy to do that. So I'll just run through real quick here. So this is asking for the radius of convergence. So the first thing we want to do is we want to find out, like, basically, like, what would I need for the ratio test to pass? So the ratio test, we take the limit as n goes to infinity, and we take one term further out, so the n plus 1 term. So x minus 5 to the n plus 1 over 2 to the n plus 1 times 2n plus 3 to the second. Oops, and I need to replace that n as well. Sorry about that. So that's going to be, if I plug in n plus 1 in there, that's going to be 2n plus 2 when I distribute, plus 3 is 2n plus 5. All right, and that's all to the second. Now, I'm going to have to divide by the term before that, or multiply by that reciprocal. So that would be, I'm going to multiply by the reciprocal, so 2 to the n, 2n plus 3 to the second, over x minus 5 to the n. All right, so from here, I'm going to clean this up a little bit, and with ratio tests, we always put that in parentheses, or in absolute values. So I'm going to have limit as n goes to infinity, and inside here, we can cancel all of those with that exponent. So I'm left with an x minus 5 in the top. All right, the 2 to the n and the n plus 2 to the n plus 1 cancels to just a 2 in the bottom. All right, the other two pieces don't really clean up much. So I've got 2n plus 3 to the second over 2 times 2n plus 5 to the second times, and I've still got an x minus 5. Now, I wrote that particularly with the x minus 5 outside because it's kind of telling us our center. All right, the center of this power series, and again, this is where we haven't done the full cover, so it's a little hard to get where it's coming from. But the center of this power series is going to be at 5. All right, but we're going to go ahead and continue this limit, which deals with n. Now, if I multiplied out the top of this, I'd have a 4n squared plus a bunch of other terms. In the bottom, I'd have an 8n squared plus some terms. All right, so we know from our old days that that limit, this piece of it, would have to reduce to 4 over 8, or 1/2. All right, x minus 5 doesn't have an n in it, so I'm really at 1/2 times x minus 5, and this was all in an absolute value. All right, now, that's the limit that I get when I do the ratio test. In order for this to converge, that limit has to be less than 1. So to solve this, we're going to say -1 is less than 1/2 x minus 5, which is less than 1. I'm going to multiply through by a 2. -2 is less than x minus 5 is less than 2. And then I'm going to add 5 to all sides. So if I add 5 to all sides, I get 3 is less than x is less than 7. All right, my center is 5. All right, so if I center this at 5, I've got 2 units out to that side, and I've got 2 units out to that side. So my radius is going to be 2. All right, because I know that I have convergence as long as I'm within 2 units of the center. So my correct answer on this one would be C. Now, again, the only thing that you would need to be able to deal with on this question would be applying the ratio test if this piece was gone. All right, if that piece was gone, then this is something, if that was a 1 over, all right, that ratio test would be something that you should feel comfortable being able to do. You would get a 1/2. 1/2 is definitely less than 1, so we could say it converges. But again, that extra step of finding radius of convergence, interval of convergence, those things are out of the bounds of what they're going to ask this year. All right, I hope that answered all your questions. Don't hesitate, just fire me an email if there's something in here you're not sure, just tell me, and I'll try and come up with an alternate way of explaining it, anything I can do to help. So I hope these 2 videos helped. Send questions from the next ones as you get to them. If you could also send me an email and just let me know that you got these and whether or not they were helpful, that would be great. Thanks, bye.